Boeing 777X's 2026 dream just got real, as after years of delays, testing pauses, and shifting timelines, the U.S. Federal Aviation Administration cleared the Boeing 777-9. The approval did not involve a public ceremony or a delivery announcement, but it removed one of the largest remaining obstacles standing between the aircraft and entry into airline service. The FAA's approval covers a major update to the 777-9's flight control software. Regulators had previously identified issues related to system behavior and flight control logic during certification reviews. These concerns were part of a broader wave of scrutiny applied to all new Boeing aircraft following changes in FAA oversight standards after the 737 MAX accidents. Until this software was cleared, large portions of certification testing and compliance validation could not move forward. The newly approved update addresses how the aircraft's flight control systems respond in specific operating conditions. According to regulatory disclosures summarized in late 2025 reporting, the FAA evaluated the revised software against updated safety criteria designed to prevent unexpected system responses. The clearance confirms that the software now meets the agency's current certification requirements, allowing Boeing to resume critical phases of certification testing that had remained stalled. This decision removes a major regulatory roadblock that had weighed on the 777-9 program for several years. The aircraft was originally expected to enter service in the early 2020s, but repeated delays pushed timelines further into the future. As of late 2025, first deliveries are now expected in 2026, contingent on the completion of remaining certification steps. The FAA's software approval is a prerequisite for reaching that target. For airlines that ordered the 777-9, the approval marks a shift from uncertainty toward planning. Many customers have waited years beyond original delivery schedules, forcing them to adjust fleet plans, extend older aircraft leases, or acquire interim capacity. With the software issue resolved, airlines can now begin more concrete preparations related to crew training, maintenance planning, and route deployment, even though final certification has not yet been completed. The 777-9 is the largest variant of the 777X family and is designed to replace high-capacity long-haul aircraft such as the Boeing 777-300ER and, in some fleets, the Airbus A380. It features new composite wings, folding wingtips to maintain airport compatibility, and updated systems architecture. These changes, while central to the aircraft's performance goals, also added complexity to the certification process under stricter regulatory oversight. Boeing's relationship with the FAA has been fundamentally reshaped over the past several years. The regulator now applies deeper involvement in certification reviews, particularly for software and flight control systems. The 777-9 software approval reflects this new environment. Rather than incremental sign-offs, each major system now requires extensive validation before the program can advance. The clearance signals that at least one of the most challenging regulatory hurdles has been addressed. The approval also carries competitive implications. Boeing has faced pressure in the widebody market as delays eroded its advantage against Airbus. While Airbus's A350 family does not directly match the 777-9's maximum capacity, it has benefited from being available and certified while the 777-9 remained grounded. The prospect of 777-9 deliveries beginning in 2026 restores a degree of balance in the large wide-body segment, particularly for airlines that require very high seat counts on long-haul routes. Financially, the delay of the 777X program has had significant consequences for Boeing. Extended development timelines have increased costs and deferred revenue, while uncertainty affected customer confidence. Clearing the software issue reduces program risk and improves visibility for both Boeing and its customers. While the approval does not end all challenges, it represents progress that had not occurred for several years. From a regulatory standpoint, the FAA's decision also reflects its approach to post-MAX safety reforms. The agency has emphasized system transparency, predictable behavior, and pilot awareness in all new aircraft certifications. By approving the revised 777-9 software, the FAA confirmed that the aircraft's systems align with these updated expectations. This sets a framework for evaluating remaining elements of the certification program. The timeline ahead remains structured but demanding. Additional testing, documentation reviews, and operational evaluations must still be completed before the aircraft can receive full certification. Boeing must also demonstrate manufacturing consistency and quality controls that meet regulatory standards. The software approval allows these steps to proceed but does not guarantee final certification on a specific date. As of December 2025, the 777-9 remains in flight testing, and certification is still ongoing. However, the FAA's approval of the updated flight control software marks one of the most tangible advances the program has seen in years. It signals regulatory alignment, reopens certification pathways, and brings the possibility of 2026 deliveries into focus after a long period of uncertainty. At a time when Boeing is under pressure to redefine its wide-body strategy, the company is advancing plans for what it describes as its most ambitious passenger aircraft concept yet, the Boeing 777-10. This plane is intended to be the largest twin-engine jet ever proposed, and Boeing views its role as critical to regaining strength in the long-haul market over the next decade. The 777-10 is a planned variant within Boeing's 777X program. Boeing has described it as the largest twin-engine passenger aircraft it intends to offer. The aircraft is proposed as a stretch of the 777-9, designed to carry more passengers on the high-density long-haul routes. Boeing has stated that the 777-10 is meant to serve markets once dominated by very large four-engine aircraft, which airlines have been retiring in increasing numbers. The concept relies on twin-engine certification rather than four engines. Boeing intends the aircraft to be powered by the General Electric GE9X, which is already under development for the 777-9. The GE9X is designed to deliver more than 100,000 pounds of thrust and meet current noise and emission capability. A central element of Boeing's plan is the new composite wing developed for the 777X family. The wing has a larger span than previous Boeing commercial aircraft and is built using carbon fiber composite materials. Boeing has stated that this wing is intended to improve aerodynamic efficiency and reduce fuel burn compared with earlier 777-10 models. Because the full wingspan exceeds standard airport gate limits, folding wingtips are incorporated into the design to maintain compatibility with existing airport infrastructure. The 777-10 is intended to prioritize seating capacity and seat mile economics rather than maximum range alone. Boeing has indicated that the aircraft is planned for routes where demand consistently exceeds what smaller wide-body aircraft can efficiently handle. These routes typically connect major global hubs with limited airport slot availability. The design assumes airlines would configure the aircraft with higher passenger density to reduce cost per seat.